the third type of FRQ that they've made for this new semester. So after we've done this one, we'll have done all three types over the past few weeks, and so you'll know exactly, the three types of FRQs. Luckily, this type of FRQ, they did release an example for, so we have an idea of, what we need for this one. This type is going to have you look at data. So let me turn on my pen here. So there's gonna be some justification here that they might ask you about. My pen a little thicker. They may ask you to propose a solution. There's some describing and explaining and identifying, but you're not likely to have calculations in here, at least the calculations that we think of where they say calculate such and such. You will see that there's a little minor calculation in this one, but it's like subtraction. So I wouldn't necessarily consider that calculation. So this is the type. This is what they say about it in the description of this type. They say you'll analyze the environmental problem and propose a solution. This means they're going to present you with some sort of environmental scenario, and then they'll give you a model or a visual representation. This means like a graph, which is what you see in the one we have today. And then they'll ask you to describe or explain the concepts in the model in written format. They'll want you to analyze the data, look at the data, and kind of see what's going on in there. And then they want you to propose and justify solutions to that problem. So, onward. So here's the example they have in the resources they released this summer for this type. It says the graph below shows the temperature anomalies from 1900 to 2016 globally and in the Arctic. And so the first thing you want to look at is you want to see that that dotted line is the Arctic, and then the dark black line is is global. And then it says refer to the graph above to answer the following questions. It says based on the data in the graph, identify. Remember, I like to underline those or put a square around them or something. The change in the difference from the average temperature in the Arctic between 1980 and 2016. Okay, so what I did is I looked at the temperature from 1980 to 2016. Okay, so the 2016 temperature, it looks like for the Arctic, is just a little bit over 1. Okay, so I called that 1.1. And you'll see that that's a positive. You see right here it's a 0. Okay, and if we look at 1980, right at 1980 you're right about here. Okay, so that's about, a little under half, maybe like 0.4, but you see it's or 0.6. You see that that's a negative. Okay, so we're going to get the difference between these two, we're going to go minus negative 0.6. Okay, so remember, if we have two negatives, it's going to be a positive, so we're going to add these numbers. So we're going to get 1.7 degrees Celsius. That's the difference in these changes. Okay, basically this amount right here is 1.7. Okay. The next thing they ask us to do is to describe. So the first one, they just wanted us to identify it. So I did that I used math to do that. But the next one they say describe. So then they want you to use words. Okay, and they want to describe the difference with the change in temperature in the Arctic with the change in global temperatures from 2000 to 2016. So let me pick a different color because I want to point something out on this graph. Okay, so when they're looking at 2000 to 2016. Okay, so you can see the Arctic is here. And during this time, you can see the Arctic is changing basically this much. and the global temperatures are changing this much. So the global temperatures are changing much less than the Arctic temperatures. So we can say, you know, the global change should be an A. Is about 0.5 degrees Celsius lower than the Arctic. Now that's still an ID, right? So I need to maybe say a little more about this. Okay, and so I said this could mean that the Arctic is warming faster than the rest of the planet, or the changes in the Arctic are faster than the rest of the planet. Okay. I'm going to write this for changes because we're running out of space. It should say rest of the planet, but I don't have space, so I just said then the rest. Okay, so there I did a little description. So that's kind of the difference. On the first one I ID'd, and so I just had to say what it was. I didn't have to say anything about it. And the second one they say describe, so I ID'd it, and then I had to give a little more information. Okay, remember we want to show these readers that we deserve college credit for this course. Otherwise they're going to say, I don't know that they really deserve college credit for that. I'm going to, you know. The other thing is, when you guys read these right now, don't look at this and go, oh my gosh, this is so hard. There's no way I can do this. This is something they expect a student at the very end of the course to be able to answer. This is not something they expect someone that's been in AP Environmental Science for a month to be able to answer. Climate change is one of the very last things that we study. And so, you know, you might not even be able to answer this question next month, and that's okay. Okay, so I don't want you to look at this question, which is something that you would see at the very end of the course, and think, oh no, I can't do this because you don't know this information yet. This is content that we will get to. Right now we're just working on like the format and the type of a question that they have. So you might want to even come back to this video in December or in April and, you know, look at it again. So now it says the cause of the temperature trend seen in the map is a result of increasing concentrations of greenhouse gases in the atmosphere. Then they say identify a greenhouse gas with a global warming potential greater than 1. Identify a source, an anthropogenic source that contributes to that. And then explain how increasing amounts of greenhouse gases in the atmosphere are linked to a change of pH. So the first part they want us to do is they just want something greater than 1. Now, carbon dioxide is basically considered our base greenhouse gas, and so it has a global warming potential of 1. There are a lot of other gases that have higher global warming potentials, and I'm going to list them here for you in case you want to write these down for the end of the year to kind of study on flashcards or something, or you're coming back to this video in April and you know, you want that list so you can have it to study for the AP exam. Now remember, you don't have to remember all of these, right? Because they just ask you to identify one. So, you know, any one of these would have been good. I probably would choose methane, which is CH4, just because that's a pretty common greenhouse gas. It's kind of an easy one. And you'll see in a second why. Okay, so the CFC is called chlorofluorocarbons. The HFC is hydrofluorocarbons. The HCFC is hydrochlorofluorocarbons. The P is perfluorocarbons. And then the last one is SF6, which is sulfur hexafluoride. So I think CH4 methane is definitely the easiest one to remember. It's definitely the easiest one to spell. So I would pick that one if this was me doing this assignment. Now for part 2, again, they just want us to identify an anthropogenic source. We don't have to say anything about it. So I would probably put burning fossil fuels as an anthropogenic source that contributes to greenhouse gases. Okay, and all I have to do is identify it. I don't have to worry about describing it because it just asks for identify. But then at the end, they kind of get you back because then they ask you to describe ocean acidification. So basically, I'm going to kind of just briefly describe ocean acidification for you. I'm not going to write the whole thing out because, I'll run out of space. I am going to write that the ocean is a carbon sink because that's important. And a carbon sink is basically a place that can kind of absorb extra carbon. So the ocean is a carbon sink and so are like forests. And so what that means is when we have extra carbon in the atmosphere, as if, most of these you see have carbon in them, the things in B1, and also carbon dioxide, which is the one that has a global warming potential equal to 1, which is the one that we talk about the most. And so the ocean is a carbon sink. So that means that when there's extra carbon in the atmosphere, namely carbon dioxide, that's the one we talk about the most, the ocean or the forest, the carbon sinks, will absorb that. Okay, so here's kind of what happens. If this is our ocean, we have carbon dioxide in the air, and it gets absorbed by the ocean. And in the ocean, it reacts with the water in the ocean. And it also, when it reacts with the water in the ocean, it forms carbonic acid. Which it's okay to have some of it because, we don't want our pH in the ocean to be too basic. But if you get too much, then the pH gets too acidic, and that's a problem because a lot of the things that live in the ocean are adapted to really narrow pH ranges, so they can't handle it getting too acidic. So I'm going to write that this is called carbonic acid. Okay, and then when carbonic acid kind of dissolves in water or dissolves in like a solution, which is basically like the definition of an acid if you've taken chemistry, is that it kind of separates into H+, which is basically the ion that means acid, and then carbonate, which is CO3-. Or CO3-2-, sorry. And so this is the big problem, is we're forming this carbonic acid when carbon dioxide reacts with the ocean or gets absorbed with the ocean, and that's going to lower the pH because, then we've got this, it's basically, all these H+ ions in the water. So that's basically what's going on there. I didn't want to write that in word form because it would be kind of long. And it would take me forever with this pen, but I did want to kind of explain it for you again in case you're coming back and you're reviewing for this, or you're just learning it for the first time. So the next thing they say is that greenhouse gases can pose threats to both human health and the environment. So then they want to describe 2 impacts that global climate change can have on human health. And they also want you to describe 1 effect of global climate change on marine organisms. See that they have describe here. That means you're going to have to say something and then you're going to have to talk about it. Okay? So you should write this in word form. Again, I'm not going to write it in like sentence form because it's just going to take me way too long. Okay? But I'm going to kind of explain it. So basically, if you have climate change, you're going to have more warm and wet areas. Okay, and you can pick whatever you want. These are just my 2 kind of go-to favorite. Let's describe what's a human problem with climate change. You're going to have more warm and wet areas, right? Because areas that used to be not so warm are going to be warm now. And you're probably going to get more extreme weather events. And so you're going to have these areas that are really great areas for mosquitoes. So then you're going to have more mosquitoes, which seems like a silly thing. So what? But it's a big problem. Mosquitoes are actually considered one of the most deadly animals on the planet, and it's not because they directly kill a lot of people, but it's because they are vectors for diseases. So you're going to have, more vectors. Right, and that's a problem because then we're going to have more diseases. Okay, you were wondering where I was going with this warm and wet climate and mosquitoes. Well, here it is. We're going to have more diseases. Okay, and more diseases will negatively affect human health. Okay, so that's my favorite. How does climate change affect human health? Example. My next favorite one is we're going to have our crops are going to decline because we're going to run out of arable land. Because again, these environments that were great for growing crops may not be great for that anymore. Or since our weather patterns are changing, that means that these areas might not get the water they need or whatever. So the crops are going to decline, which means we have less food. Which means we're probably going to have more malnutrition. This one's probably a more obvious one, but I like the mosquito example. So that one's my favorite. I always put that one first if they ask about that. The next thing they want us to describe effect global climate change can have on marine organisms. Again, I'm just going to write this kind of in arrow form again. You should write it in sentences, but it takes me long enough to write it like this. It would take me forever to write it that way. So, what did we just talk about? We just talked about ocean acidification. So we could say, man, I cannot spell today. Okay, so ocean acidification is going to do what? It's going to reduce the pH, right? Which means we're going to have a decline in coral reefs, because coral reefs are one of the main things that are adapted to these really narrow pH ranges. And we're already seeing a loss of corals due to ocean acidification. Okay. Then you can say this decline in coral reefs could cause a loss of habitat. You could say the decline in coral reefs cause a loss of spawning locations for fish, or corals for that matter. And then you could also say that it was a loss of like fish nurseries, because that's also, you know, a place, a function of coral reefs. And you'd only have to put one. But I'm putting them all because I was kind of hoping to kind of teach you guys a little bit about environmental science while we're talking about the types of FRQs. Okay, now the last part is it says in order to reduce the effect of greenhouse gases on ecosystems, greenhouse gas emissions must be reduced. So how are we going to do that? We want to propose a realistic solution to reduce greenhouse gas emissions, and then we want to justify how that solution is going to reduce greenhouse gas emissions. So you could put a whole bunch of stuff in here. You could talk about driving electric vehicles. You could talk about, you know, going to the LED light bulbs. You could say whatever you want. When I was kind of writing this out, I chose stricter emission regulations on vehicles. That was my first thought, so I was going to go with that. Like I said, you can pick whatever you want, but one of the things I would recommend is, like, for this one, I would read both parts, because you don't want to pick a solution and then not have a really good way to describe how that's gonna lead to a decrease in greenhouse gases. So I read both parts and I was like, ooh, I know a really easy way to describe or justify stricter greenhouse gas regulations, so I'm going to use that one. Okay, so for this one, I said that stricter regulations. I'm going to try and write this again, not in sentence form, but you need to write in sentence form. I just like I said, it'll take me forever. So stricter regulations means that new vehicles would have to conform to these standards. Okay, and if new vehicles are conforming to these standards, that means they're going to have lower emissions. Which means they're going to produce less greenhouse gases. Okay, you could say lower emissions, especially carbon dioxide, or whatever you want to do. You could just say lower emissions. So that's kind of how you would work through this type of FRQ. If I'm perfectly honest with myself, I thought this one was kind of difficult. So if you think it's difficult, that's okay. You don't have to feel bad that maybe you didn't know how to answer all of these right away. You've only been in class a month. Okay. I thought this one personally was a little bit difficult. And so, you know, it's okay if you think that as well. So that's that third type of FRQ.